So let's talk about capacitors. Capacitors are an electrical energy storage component and store the energy between two charged plates, forming an electric field. The unit for this charge capacity is measured in farads, but is usually measured in much smaller forms such as microfarads. This unit is named after the late physicist Michael Faraday. In most capacitors, a dielectric is present, which increases the amount of charge based on the permittivity constant of the material. When a capacitor is supplied with a DC voltage, electrons will travel towards the positive plate, which creates an imbalance of charge, hence creating a voltage. This period is known as the transient period, but more on that later. When adding the total capacitance of a circuit, it is important to consider whether the capacitors are in series or in parallel. For parallel capacitors, it is rather easy to evaluate the total capacitance. You just simply add the capacitance values together. However, when the capacitors are in series, you must add the inverse of the capacitance, and then take the inverse of the resultant value, just like calculating resistors in parallel. Now let's talk about charging and discharging phases. The charging phase, the transient period, is a period in which the capacitor rapidly charges over a total of 5 time constants. But what exactly is a time constant? Simply put, it's a value that is calculated by the total resistance and the total capacitance multiplied. One time constant is the time taken for the capacitor to charge 63.2% of its maximum charge, and after 5 time constants have elapsed, the capacitor is considered to be fully charged. This fully charged state is known as the steady state period. Shown above, in the steady state period, no current will flow, hence the capacitor acts as an open circuit. In the discharging phase, the charged plates begin equalizing, creating a current that flows in the opposite direction and a decreasing voltage. Using the shown formulas, we can calculate voltage and current in the transient period and discharging phases. Now for an example. In the above circuit we have 6 capacitors in parallel. What would the resultant capacitance be? Either A, 31 microfarads, B, 1.1 microfarads, C, 47 microfarads, or D, 14.3 microfarads. If you chose answer C, you are correct. Since the capacitors are in parallel, we simply add the values together, which add up to 47 microfarads. And that's all for capacitors and DC networks. Thank you for watching, and I hope you learned something that you may not have known.